Angles. Because many applications involving circles also involve a rotation of the circle, it is natural to introduce a measure for the rotation or angle between two rays, line segments, emanating from the center of a circle. The angle measurement you are most likely familiar with is degrees, so we'll begin there. Measure of an angle. The measure of an angle is a measurement between two intersecting lines, line segments, or rays, starting at the initial side and ending at the terminal side. It is rotational measure, not a linear measure. Measuring angles. Degrees. A degree is a measurement of angle. One full rotation around the circle is equal to 360 degrees, so 1 degree, 1/360th of a circle. An angle measured in degrees should always include the unit degrees after the number or include the degree symbol. For example, 90 degrees equals 90 degrees. Standard position. When measuring angles on a circle, unless otherwise directed, we measure angles in standard position, starting at the positive horizontal axis and with counterclockwise rotation. Example 1. Give the degree measure of the angle shown on the circle. The vertical and horizontal lines divide the circle into quarters. Since one full rotation is 360 degrees, each quarter rotation is 360 divided by 4 equals 90 degrees. Example 2. Show an angle of 30 degrees on the circle. An angle of 30 degrees is 1/3 of 90 degrees. So by dividing a quarter rotation into thirds, we can sketch a line at 30 degrees. Going Greek. When representing angles using variables, it is traditional to use Greek letters. Here is a list of commonly encountered Greek letters: theta, phi, alpha, beta, gamma. Working with angles in degrees. Notice that since there are 360 degrees in one rotation, an angle greater than 360 degrees would indicate more than one full rotation. Shown on a circle, the resulting direction in which this angle's terminal side points would be the same as for another angle between 0 and 360 degrees. These angles would be called coterminal. Coterminal angles. After completing their full rotation based on the given angle, two angles are coterminal if they terminate in the same position. So their terminal sides coincide, point in the same direction. Example 3. Find an angle theta that is coterminal with 800 degrees where 0 degrees is less than or equal to theta less than 360 degrees. Since adding or subtracting a full rotation, 360 degrees would result in an angle with the terminal side pointing in the same direction, we can find coterminal angles by adding or subtracting 360 degrees. An angle of 800 degrees is coterminal with an angle of 800 minus 360 equals 440 degrees. It would also be coterminal with an angle of 440 minus 360 equals 80 degrees. The angle theta is 80 degrees is coterminal with 800 degrees. By finding the coterminal angle between 0 and 360 degrees, it could be easier to see which direction the terminal side of an angle points in. On a number line, a positive number is measured to the right and a negative number is measured in the opposite direction, to the left. Similarly, a positive angle is measured counterclockwise and a negative angle is measured in the opposite direction, clockwise. Example 4. Show the angle negative 45 degrees on the circle and find a positive angle alpha that is coterminal and 0 degrees less than or equal to A less than 360 degrees. Since 45 degrees is half of 90 degrees, we can start at the positive horizontal axis and measure clockwise half of a 90-degree angle. Since we can find coterminal angles by adding or subtracting a full rotation of 360 degrees, we can find a positive coterminal angle here by adding 360 degrees. Negative 45 degrees plus 360 degrees equals 315 degrees. It can be helpful to have a familiarity with the frequently encountered angles in one rotation of a circle. It is common to encounter multiples of 30, 45, 60, and 90 degrees. These values are shown to the right. Memorizing these angles and understanding their properties will be very useful as we study the properties associated with angles. Angles and radians. While measuring angles and degrees may be familiar, doing so often complicates matters since the units of measure can get in the way of calculations. For this reason, another measure of angles is commonly used. This measure is based on the distance around a circle. Arc length. Arc length is the length of an arc, S, along a circle of radius r subtended, drawn out by an angle theta. It is the portion of the circumference between the initial and terminal sides of the angle. The length of the arc around an entire circle is called the circumference of a circle. The circumference of a circle is c equals 2 pi r. The ratio of the circumference to the radius produces the constant 2 pi. Regardless of the radius, this ratio is always the same, just as how the degree measure of an angle is independent of the radius. To elaborate on this idea, consider two circles, one with radius 2 and one with radius 3. Recall the circumference perimeter of a circle is c equals 2 pi r, where r is the radius of the circle. The smaller the circle then has circumference 2 pi multiplied by 2 equals 4 pi, and the larger has circumference 2 pi multiplied by 3 equals 6 pi. Drawing a 45-degree angle on the two circles, we might be interested in the length of the arc of the circle that the angle indicates. In both cases, the 45-degree angle draws out an arc that is 1/8 of the full circumference. So for the smaller circle, the arc length is 1/8 multiplied by 4 pi equals half pi. And for the larger circle, the length of the arc or arc length equals 1/8 multiplied by 6 pi equals 3/4 pi. Notice what happens if we find the ratio of the arc length divided by the radius of the circle. Smaller circle, half pi divided by 2 equals 1/4 pi. Larger circle, 3/4 pi divided by 3 equals 1/4 pi. The ratio is the same regardless of the radius of the circle. It only depends on the angle. This property allows us to define a measure of the angle based on arc length. Radians. The radian measure of an angle is the ratio of the length of the circular arc subtended by the angle to the radius of the circle. In other words, if S is the length of an arc of a circle and R is the radius of the circle, then radian measure equals S divided by R. If the circle has radius 1, then the radian measure corresponds to the length of the arc. Because radian measure is the ratio of two lengths, it is a unitless measure. It is not necessary to write the label radians after a radian measure, and if you see an angle that is not labeled with degrees or the degree symbol, you should assume that it is radian measure. Considering the most basic case, the unit circle, a circle with radius 1, we know that one rotation equals 360 degrees. We can also track one rotation around a circle by finding the circumference. C equals 2 pi r, and for the unit circle, C equals 2 pi. These two different ways to rotate around a circle give us a way to convert from degrees to radian. One rotation equals 360 degrees equal 2 pi radian. Half rotation equals 180 degrees equal pi radians. 1/4 rotation equals 90 degrees equals pi over 2 radians. Example 5. Find the radian measure of 1/3 of a full rotation. For any circle, the arc length along such a rotation would be 1/3 of the circumference. C equals 1/3 multiplied by 2 pi r equals 2 pi r divided by 3. The radian measured would be the arc length divided by the radius. Radian measure equals 2 pi divided by 3.